Hi everyone, hope everyone's doing well. Right now, since it's the last week of school, and because of that, I'm going to try to clarify some topic, which is the Spanish tree here. I will go over some basic definition and also go into detail about the two algorithms, which are cross-code and the primes algorithm. So, Spanish tree, it is a graph, a connected graph that is like a tree which include all the vertices and it spans in the graph. So it's kind of similar to the graph or the BFS best first search and the best first search graph because like it just has all the vertices and then it spans out to more vertices and connected with using the edges, so everything's connected. That's what is spanning tree called. And in particular, there's a minimal spanning tree. So many application area like the communication, electronics, or the transportation require to find the lowest cost way to connect a set of object or location. Like the cost may be measured in the term of currency or distance. So we can model such situation with weighted graphs introduced in the which introduced in the textbook. And there's we want to find a spanning tree with minimum cost. So like salesman wants to find the smallest distance from one place to another place so they can um, send the mail to people like faster, and also you can pick the like smallest route from your home to another place so you can save time. That's what is a minimal spanning tree look like. And in the picture, there's a graph of minimal spanning tree. It's like each vertices is connected with edges, and it has like number on there on the edges, which is the weight of the graph of the edges. That is why it's called weighted graph. And it's being picked. It will pick like the minimal one, like the lowest one, not the highest one. So for the algorithm for this kind of type of tree, there's two. So the first one will be the classical algorithm. So this algorithm it starts with each vertex being its own component, and you repeatedly merge two components into one by choosing the light edge that connects them, and it does this greatly. Greatly means like from top to bottom, top down. That's what is grading mean. And then by scanning the edges in increasing order by weight. Then and also this algorithm has similarity with the connected component algorithm, which I think you already learned it from the best first search or the depth first search, because it measures the depth first search measures the connected component algorithm. Okay, now let's go over the pseudocode for this algorithm. So here is the pseudocode in in the on this page on here, and it might look different than the one from the textbook because I like this kind of one better than textbook, but I think some of you guys might like the textbook one better. You can choose either one because it is same. They're all the same kind of same for the um, algorithm because they're both for critical. So it just does the same thing I said. Like you start from one vertex and then you goes to other vertices, and you will sort the edges, pick the edges from the lightest to the least lightest. and then until you reach all the points in the graph or the tree. And then here is a example. So like you see, the first edge has been chosen in the step A, which has a arrow here pointing here. That's the first edge, and then we can add more edges, like I said, 4 more edges, which is in the step E. So which added like the 4 right here, AB is weighted will be 4, and the weight for the IC will be 2, and then CF will be 4, and then the 2, which is GF, and then yeah, because those are the lightest one that can connect majority of the vertices, and then the next edges um you don't really add because it already connect the vertices. So now you just need to figure out like if you can add more edges to connect more of the vertices, but make sure you don't add too much edges to like um have too many things, because you want it the least amount of edges, but they connect all the vertices. And if you want to know the answer to this problem, you can email me and I will tell you, or you can work it out yourself and ask me for the answer. Or if you need more detailed explanation, you can also email me to ask me about it. I will happy to help you understand this. And let's talk about the primes algorithm now. So this algorithm is also a gradient algorithm like the Kruskal one, but it builds one tree and then choosing the lightest edges on the growing tree, like in the picture. So it's so that the set A is always a tree. A tree is initialized to be a single vertex, designated R for root. So at each step, it finds a light edge crossing the cut VA to VA. So where AA is the vertices that are incident on A and adds these edges to A. So initially the A will have nothing in there, and then VA will have a R in there. Here is in the picture, and in the bottom has a picture of it, how that works. So like it starts from one in the middle, and you have like all the edges out. So edges of A are shaded, and then it will be shaded. That's the edges, and it will be choose the lightest edge. And here is the pseudocode for this. And again, this one is different than the one from textbook, and you can choose to use either one. Depends on which one make you understand this algorithm better. Um, yeah, and I just did the similar thing I said. And so it is possible in this code, it is possible that for the last if statement, so the line 10, to execute multiple times for a given v. So in other words, you may find like an edge reaching vertex v, but before we choose to use it, we find another edge reaching the v for the lowest cost. So yeah, you will encounter this situation, but eventually you will reaching the end. So you will see in the next example. So here's an example of it. So for this one, you start from 8 in step A, and then you choose the lowest edge between the one reaches for B or the one reaches H. So one has a 4 and one has a 8. So yeah, you just choose the 4 is the lightest, so you choose 4. So that's why you in the step B you can see that 4 being highlighted in gray, and then it goes to B, and then from B you can goes to H or goes to C, but like the one goes to C has the lighter edge, so then you just go to C, and because it has an 8, 8 is smaller than 11, so you go to C, and then from C you can go to the D, I, F, but I has a lighter weight, so you goes to I with 2 will be the weight of the edge, and then just continue to the end. If you want to know the final answer for this question, again, you can email me, or you can just try it yourself first and then ask me for the answer too. Or if you have like question about it, you can also ask me. And hopefully this um, make clear like make it clear about the both algorithm for minimal spanning tree, which is the classical algorithm, and also the prime. So, and if you have more questions, you can always welcome to email me, or schedule like a Zoom meeting with me too. I'm happy to like answer any question you have, and have a good week and good luck on your finals.